I'll put it onto the website when I have a spare moment at the weekend, if you'll just forgive me for running until then. Okay, thank you. Thanks, Lester.
Thank you very much. Daniela. And good morning, folks, and welcome to the summer school. I'm hoping that my mic is sufficiently loud enough, so if you cannot hear me at the back, I'm good. Okay. My testers at the back have arrived, and they've told me that my volume is good. So thank you very much for attending this week. We're going to have a bit of an adventure this week, an adventure that will start today, and that will end, hopefully, with you learning a little bit more about yourself, more than about me, and almost more than about the subject. For those of you, so let me start by saying what I'm not, okay? I'm not female, obviously. I am not a medical doctor. I'm a PhD, and I'm not a dermatologist, even though I work extensively with the dermatologists. I wish I was a surgeon, but I'm not. So, so what I am is a molecular and cell biologist, and that's what I've trained in, with a specialty really in skin research. And so I've spent the last 10 to 12 years really trying to understand not only the skin from a biological point of view, but also the skin from a psychosocial point of view. And that culminated last year in a very nice interdisciplinary collaboration with the social sciences, where we could look a little bit deeper at what make people try to change their skin color, and what is their thinking behind it, and what is the sort of mindset of people wanting to change their skin color, whether it be darker or lighter. And so this week, we're going to progress down this adventure where we're going to look at lots of things. And I urge you to be very interactive with me. I promise I don't shout at people. I do enjoy the interaction, and there are so many topics, there are so many nuances around the subject that I would like you to raise some of them. If I am going to cover them in the lecture series, I'll let you know. If not, I may flag it, and we'll come back to it, I promise. And so let's be interactive. So just, breathe in, breathe out, relax. This is not a note-taking lecture. It is hopefully very visual, and I'm hoping that we learn quite a bit as we go through this week. And I'm also hoping that you can teach me through your questions how far we still need to take this research. All right? So let me start by giving you a week overview. And this adventure is going to start today, where we talk about what is skin, what makes it important, how do we get our skin, how do we get color in our skin, what generates the color, how we can alter that color, for example. And then a few myths. I will end with a few myths that need to be dispelled almost immediately. I will also have a session right at the end of virtually every lecture where I have a frequently asked questions session, or a Q&A, a question and answer session, which is just an open forum, all right? We've sealed the doors, so if you want to ask any personal questions, please go ahead. Nothing leaves this room between you and I. So tomorrow we'll look at, and I really want to, let me just go back. The title of this week's lectures was The Skin, the Good, the Bad, and the Ugly. But we don't like to call things ugly. So I've changed it. The good, the different, and the not so good. All right? And so we'll use that thematic approach as we go through the week. Tomorrow we'll look at skin physiology. What is UV or ultraviolet radiation? How does that affect us? What is SPF, sun protection factor? We see SPF 10 and SPF 20 and SPF 50, and add this and add that and take of this and take of that all over our television sets and all over the media. We'll explore a little bit what it is. And then, of course, the aspect of can we go into the sun? And if we do go into the sun, how long do we go into the sun? Or should we just avoid sun altogether? And that relates to vitamin D. We'll talk a little bit about folic acid and folate. In lecture 3, we'll talk about the skin as the different. The different, where we talk about tattoos. What are tattoos? How do we get tattoos? Are they permanent? Are they not so permanent? Are they terrible? Are they nice? We'll talk about tanning. If you want the perfect tan, that's your lecture to be in. And then we also talk about my other pet subject, which is skin lightening. Skin lightening and why people lighten their skins. And it's a very hot topic at the moment because the cosmetics are just filled, the cosmetic shelves. And this is where I go into a pharmacy and my wife has to come call me out after an hour and a half because I'm standing in front of the cosmetic shelf for the last hour just looking at the whole range of products and reading every bottle as we go along. So skin lightening and what it is it a farce? Is it just a means of a sale or not? Lecture 4 is what I call the bad and what happens when things go wrong. We'll look at a few skin pigmentary disorders. We'll look at what happens when skin actually burns. And that's my other pet subject, which is burn research and the terror of being burnt and what actually happens and how the skin heals after that and what we're currently doing relating to burns research. And then cancers, skin cancers, non-melanoma and melanoma skin cancers. We'll delve into what it is and see what the current treatments and the theories around healing people with skin cancers are. Lecture 5, I finished the week with a lecture called Hope. And this is skin research and the incredible commitment of researchers worldwide to try to find answers relating to not only cancers, but the biological mechanisms that relate to cancers. And so we'll look at the current skin research. We'll look at current treatments. I'll also throw in there what my lab has been doing. I left UCT last year, at the end of last year, to start my own lab. And so I'll chat a little bit to you about what we're planning to do going into the future relating to skin research. All right? Sound good? Yeah. All right. So let me start and say that if you were to describe skin, it is 6 million years old. We expose it to the elements in all sorts of ways. We cover it, we paint it, we tattoo it, we scar it, and we pierce it. We do a whole lot of other things to it as well. We stretch it, unbelievably, actually. When you sit back and you think about your skin, you think about you've only given one, right? Just like your heart, I guess. But this is a little bit different because your heart, your lungs, your kidneys, although you have two, are protected, very much protected against the elements, whereas skin is not. And so evolutionary-wise, we needed to produce a material that was waterproof, that was stretchable, that allowed stretch because you only got one and it has to grow with you, okay? And yet we do all sorts of things to it, and the bottom line is it continues to heal and continues to grow. Of course, like any living organ, it gets old, right? And so after many years of stretching, something that gets old and something that loses its stretch underneath starts to pull back and wrinkle. And we'll also look at that a little bit later in the week. Just a few fun facts about skin. Skin itself is 1 to 2 millimeters thick. And when I talk about 1 to 2 millimeters, we as scientists normally talk about microns, which is 1,000th of a millimeter. And so 2,000 millimeters is just about the thickest skin around the body. All right? We have different thicknesses of skin as we look at different regions of your body. Who would guess what the thinnest skin of your body is? Where does it sit? Let's get some eyelids, and believe it or not, ears, okay? Ears. Just around the cusp of the ear is actually part of the thinnest skin on our body, and that's also one of the most highly susceptible areas for sunburn and also obviously for developing cancer. And so we find quite a lot of non-melanoma like basal cell and squamous cell carcinomas arising around the ears. The funny thing is that people know about this, they're very much aware, and yet they wear hats and caps that expose the ears, which is, this is a lecture that I should give to golfers, but I'll leave that for another time. The other fun thing about the skin is that it is roughly 2 square meters wide. If you were to cut your skin off and place it down, you'd get an area of about 2 square meters, 2 by 2. And that, don't forget, you can also stretch, because the skin by nature is a stretchable material. Not only that, the skin itself can be, besides being stretched, the skin can be cut, and it heals pretty well, all right? We'll also get to the different shades of skin. And so with all of that, our skin really is the canvas of life. I think the most important thing is that skin in itself is a first impressionable organ. It's one of the organs that leads to lots of heartache, lots of controversy, and we'll touch a little bit on that, but also that your skin is what you see when you first meet someone. And so it becomes very important as a canvas as to how we treat it, right? You treat your skin well, it will treat you well. The skin itself, and unfortunately, yeah, I'm talking to the males in the audience, is defined as the largest organ of the body, okay? And we'll move on from there. Now, the skin itself has been used as metaphors, or metaphorically, in a number of ways. And if I were to tell you, we're now going to switch to an English lesson, and I were to say, do you know of a quote that uses skin in it? You will say what? Throw a few out at me. Skin deep, thick-skinned, do not get under my skin. And so we relate, thank you, so we relate the skin to a number of emotions as well. By the skin of my teeth. He is so thick-skinned. We've already heard it. Beauty is only skin deep. We hear that often. He's only skin and bones. Getting under my skin. No skin of my nose. All right? And so one can see that as we moved through the centuries, skin has continued to be held in high esteem, not only in biology, but in the English language. Shakespeare, in one of his sonnets, described a lady in the most beautiful way. I don't have the full quote, but he spoke about your milky white, right? Your milky white and flawlessness that is reflective. And there he was talking about the skin. Okay, he was angling at the breasts, unfortunately, but that's just what Shakespeare was. All right? So we carry on. So let's talk a little bit about human skin and what it actually is. And here I'm going to take you back to a biology lesson very quickly. Excuse me. And I'm going to take you right back to your Biology 101 class. And please, if I'm boring you now, just hang with me, because we need to go over a few details. So this is, if you were to take your arm and you were to chop off your hand, and you were to look at the skin from the front, all right? Obviously magnified. This is 2 millimeters thick, so we magnify it. The skin itself is made up of 3 layers. The epidermis on the top, the dermis, and the hypodermis. And each of these layers reflect exactly what we need for the skin. So the upper layer is called the epidermis, and the epidermis consists of 2 major cell types, which we'll get to in a second on the next slide. And those cell types are important. Why? Number 1 is protection, okay? The keratinocytes, which is the one cell, and the melanocytes, which are the other cells, reflect not only protection, the keratinocytes, but the melanocytes themselves are the pigment or color-producing cells in the skin. And those are very important and highly controversial cells. But we love them. we love growing them, we love looking at them, and we love trying to understand them. So that's the epidermis. Only 2 cell types, all right? Only 2 cell types, thick, multiple layers of cells on each other, and even in that, not many layers before you get to the dermis. Now the dermis, which is the middle portion on the slide, is the area which contains all the sensory information. So it not only contains the nerves and the blood vessels, and these are reflected over here in white, the nerves, the red and blue are your blood vessels, your veins and arteries. It also contains proprioception or sensory receptors, okay? It also contains glands, right? And so if you're sitting in the sun, how does the skin react? You start to increase the heat, you start to sweat, okay? Sweat is there to cool down the surface of the skin, and so of course you need to know. So as the sun reflects down onto the skin, it has to be sensed that it is getting hotter via the vessels and via the nerves, and then your glands respond to secrete sweat onto the surface. The sweat is there. As the wind goes over it, it cools down, and it cools down the surface of the skin. That's your dermis. Lower than that is your hypodermis, which is just your fat layer, which is the area that you're sitting on right now. All right, so for many of us, or for some of us, in certain areas, of course, these ratios will differ, okay? On the soles of your feet and the palms of your hands, for example, epidermis is a lot thicker, all right? It also has the upper layer, which is called keratinized layer, the very hard layer, the scaly layer that you have on your heels that you try to get rid of, okay? That is made up of cells that have actually been compacted. And those are, of course, very important. Why? Because they are the most abrasive areas of the body, all right? You walk on your hands, you walk on your feet, and you use your hands, all right? The other fun fact is that, of course, this is a living organ, and so every day these cells divide, like cells should if they're alive. They divide into new cells, and so we get a replacement of this upper layer all the time, okay? Obviously, not all at once, so it varies, and that's why over a period of a year, we lose approximately 1.5 kilograms of cells off the surface of your skin. Okay? Let me repeat that. In the course of a year, we lose about 1.5 kilograms of cells off the surface of your skin. How we know that? Well, it's nicely reflected in a quick visual, and that is when you get out the bath, okay? If you bath, I shower, but my wife baths. So when you get out the bath, there's a nice rim around that bath that you normally have to use handy Andy to get rid of. That, folks, is skin cells, all right? And it is literally needed because as you take the surface skin cells off, the new skin cells below get activated to divide and divide. Now, obviously, we can artificially do that, and ladies will know about a chemical peel, all right? Or a strip peel, where literally they put some sellotape on the surface of your skin and they just rip it, all right? And what they're actually doing is they're removing that layer. It's sort of equivalent to about 100 baths, okay? They're removing that layer, and so that they're activating the lower levels of skin cells to divide, and so they push up. So in theory, you're getting newer cells or a newer surface of your skin much earlier than you would after 100 baths, okay? Right, so those are the 3 layers. Now the question is, what makes skin so special? And we've already spoken about protection. We've said that every open surface of the body is protected by skin, and it runs pretty deep. Temperature control, we've already spoken about. As soon as your skin heats up, you start to sweat. That is activated via sensors in the same way when we get cold, right? What does your skin do? It starts to shiver. And together with that, and something that we're not really going to speak about this week, but you cannot extricate skin from hair. And they really work together in a marvelous unit. And so, for example, when we get cold, the skin is activated and starts to activate the hair follicles. And that activation of hair follicles, when you look at your skin, what happens? You've got goose flesh, right? And that goose flesh is in fact telling you that the hairs, the very fine hairs on the surface of the skin has been activated, and where they normally sit at a 45-degree angle, the hairs in the skin, when you get cold, the hairs are actually pulled up into a 90-degree angle, perpendicular to the surface. And why they do that is so that they can trap the air flowing above the surface, so that air gets trapped and gets warmed up, and thus warms the skin in order to increase the overall body temperature. All right? Temperature control, of course, it is sensory. If I were to ask the lady in the second row, the lady behind her, to touch her back anywhere on her back, and your back is huge, right, biologically, compared to cells, she would know exactly. She would be able to probably pinpoint just about the exact point that the lady has touched her back. Okay? Not only is it super sensitive, it works almost better than a GPS. It defines us. It defines us as a species. And here, let's put our heads together to try to work out these species. Let's hear. This is the skin of a almost rhino, zebra, or snake, reptile. This? Ha! I thought I'd just throw that one in, just to keep us awake this morning. That is the skin of a dinosaur. Okay? It is. Okay. Let me also just right now, which I didn't do at the start of the lecture, declare no conflict of interest. If you see any photographs that I do have has been sourced from the internet, and any photographs other than that have been gotten permission to show you guys. And so let me just declare that.
But some of those photos aren't skin.
Some of those photos are not skin. It is the hair patterning on the surface of the skin. Absolutely. So what you would see there, and that's a good point, something like this is not the skin, it is the hair, and the skin underneath is a different shade. But interestingly, the color of the hair is reflected via the cells from the skin. Okay? Because those same skin cells that give our skin its color also give your hair their color. And so we'll chat a little bit about that. But thank you for pointing that out. It also defines us as a culture. What we do to our skins generally is associated with identification. Okay? And here we're not necessarily talking about the color, even though that also identifies us. We're talking about what people can actually do to their skins, right? They can do all sorts of things to their skin. They can adorn it. They can try to change the color of it. They can paint it, and they can scar it. Okay. Skin itself, it's the toughness and elasticity of it helps in things like scarification. Okay, a very common practice. In the South American tribes, for example, where the more scars you have on your skin, the greater warrior you are. Not only that, the scarification practices also identifies the tribe. So, the warriors of a particular tribe will have 6 vertical stripes on the back of their back, on their backs, whereas other tribes may have 4 horizontal stripes or scars on their backs, and so forth. It also is elastic. And when we talk about elastic, when we talk about extremes, we talk about these types of discs which are inserted into the lower lip. And so what they would do is cut the lower lip and immediately after the cut, they'd insert the plate. Okay? The plate itself reflects their tribe, and very often it is also the females who would like to decorate it. So the best sort of decorated plate wins the man at the end of the day. But this is a portion of her lip stretched around it. Of course, you can only do that once you remove the plate. That lip hangs because you can only stretch the skin to a certain point before it recoils and before it loses its recoil. All right? And then don't discard your CDs just yet, because we can also put them through our noses. But that's just further decoration to reflect the toughness and elasticity of the skin. And of course, for expression, right? Skin has been used many centuries for expression not only of cultures, like the henna tattooing for Indians, but also expression of beauty, expression of individuality, and all sorts of other reasons. We have incredible colors that we can put in the skin these days, and we'll talk a little bit, I think tomorrow or the next day we'll talk about tattoos in detail. So, skin in itself is also a politically related organ, I call it. And that has been a massive controversy, and really socially the skin, and I hope that at the end of this lecture series you will see that all of our skins are pretty much the same, except for a few shades. We virtually have identical biological organs. Okay? However, if you were to look at the Freedom Charter, and I paraphrase this, the Freedom Charter, the Constitution of South Africa, the US Civil Rights, if you were to take just about any civil rights declaration or any freedom charter of any country, you will probably get something like this, where the rights of the people shall be the same regardless of race, color, or sex. All laws which discriminate on the grounds of race, color, or belief shall be repealed. Okay? Where they hid this in South Africa, I'm not quite sure. But nevertheless, if you carry on, and here's a very good friend of mine, for those of you who may or may not know her, Nina Jablonski. Professor Nina Jablonski is a very well-known, world-renowned biological anthropologist who hails from Pennsylvania State University. And I was fortunate, she's a good friend of mine now, I was fortunate to spend 3 months with her last year on sabbatical. She's looked at at the color of our skin, evolutionary-wise, and if there are 2 books that I can recommend, I would recommend her 2 books if you're really interested. The one is Skin, A Natural History, and I can show it to you later, and Living Color, which is her latest book, looking at the biological basis and the social basis of skin color. And what she stressed was that races do not exist, and that races are only social constructs. Okay? If you were to drive the racism story on the basis of biology, there is no race, right? So, how else would you socially construct a race? Well, it had to be somebody, somewhere, that decided on what the social constructs are that are associated with different skin colors. Despite ever more genetic evidence confirming the non-existence of races, we still use it everywhere. And as she says, we use it to identify inferiority and superiority right across cultures. And so maybe the time is now to start really looking again at what the biological basis of skin color actually is. And we'll get to that in a few minutes. We see that it is based on the mistaken belief that differing intellectual capacities and potential moral resolve and behavioral predilections are related to skin color. And this was just a short excerpt from one of the chapters, just stressing the fact that how can we use skin color as a differential between people if biologically they are identical. All right? So, just to remind you again, because it's going to be important as we go forward, that we have the epidermis, the dermis, and the hypodermis. And what I now want to look at and zoom in on is this area over here, which is the epidermis. Okay? And I said that the epidermis has how many cell types? 2. Great. We're all here still. We've got 2 cell types. We've got the keratinocytes, or the keratinocytes, and the melanocytes. And it is the interaction of these 2 cells that is highly important when we look at the skin. So I'm just going to give you a second to try to get that into your head, because it's a little bit of a 3-dimensional picture. What I want you to look at is the green is a cell and the blue is a cell. Okay? And so for those, I apologize for those who are biologically inclined that this might be boring, but for those that are not, okay, this represents a cell, and don't forget that this cell is in 3 dimensions, so it's actually sitting in a space in your skin. This is the melanocyte, and your immediate comparison here is that this looks very different to the green one, right? The green looks very different to the blue, right? And so it is. And so the melanocyte is likened to a hand, okay? Hand, which has the nucleus of the cell in your palm, and the rest of the cell are your fingers, which are the dendrites, okay? And the dendrites are exceptionally important because it is the dendrites, as you can see here, that extend into and beyond the surrounding keratinocytes, okay? So the keratinocytes themselves are connected to each other very tightly, right? So right over here, for example, like a jigsaw puzzle, the keratinocytes are connected to each other, and of course they have to be, because your skin is very abrasive, you know? You don't just knock against something and half your skin falls off, right? So it has to be very tightly regulated. It is also, for that reason, a very good protective surface, in that it is so tight, it very often prevents viruses and bacteria from getting through the surface. And so we can very easily wash off the viruses and bacteria, and because it is oil-based, right? It is therefore waterproof, and so you can wash it off quite easily. So, however, the melanocytes have to sit and extend their dendrites in between the keratinocytes. Why? Because the keratinocytes have an integral conversation every day, right? They need to speak to each other every day, all the time. And in fact, we call it the epidermal melanin unit, and I'll come to the word melanin in a second. So let me use a good example here. The example of a cement factory, right? In a cement factory, and if we liken the melanocyte to a cement factory, we have the cement floor, which is, or the head office, or the main office, which is the brains behind the business. And it is on the cement, on the factory floor, that we start the production, right? And what is the aim? The aim is to produce cement, obviously, on the one side, and then to put it into bags, and then to transport those bags out of the factory. And that is exactly how the melanocyte works. The melanocyte is there primarily to make melanin, which is the pigment, to put it into a bag, and then transport that bag on its conveyor belts, which are the dendrites, transport those bags up and along the conveyor belts and send those bags to the keratinocytes, okay? And only once it is in the keratinocytes do we actually start to get skin color. And we'll look in a second at what is the importance of that pigment. And so these transporting bags are exceptionally important, okay? And now one starts to understand that if I were to stop the production of the bag, right, what happens? We do not get transfer of the bags, right? So if the conveyor belt had to stop there, we do not get the transport of the bags, we do not get the transfer of the bags into the keratinocytes, we do not get color, all right? And so scientists, very long and hard over the past many years, have been looking at mechanisms where they can actually stop the bags, not only from being transferred, but stop the bags from being made in the first place, okay? Some skin disorders, for example, have a problem with making the bags, and so you don't get the pigment. Some skin disorders have a problem with transferring the bags, so they make the bags perfectly. They transport the bags, but just the point where they have to transfer it to the surrounding keratinocytes, it breaks down. And so genetically, due to mutations, you do not get the transfer. That too will not lead to skin color or lead to a lack of skin color. And so that is how the production of these bags or these pigment relate. But let me just go a little bit deeper into one of these bags so that I can show you how this pigment factory works. And so if you were to take one of these bags, and we call it, because it comes from a melanocyte, it's called a melanosome. And please do not get into the details of all of this. What I simply want to show you is that two important points here is the yellow, which is an enzyme that is needed by the cell. And I'll explain why I'm highlighting this enzyme. This enzyme, tyrosinase, which you don't need to remember, is the enzyme that drives the production of the pigment, okay? So essentially drives the production of the cement. And it is only this enzyme that starts the production. So if you do not have this enzyme, you do not have the production of pigment. You end up with a perfectly looking melanosome with nothing in it, all right? Tyrosinase is an enzyme, and when it is genetically mutated, you get no tyrosinase, you get no pigment. That condition is called albinism, okay? And you all know, you all have seen albinos. You know that albinism is a lack of pigment, and these albinos lack pigment in every area that has melanocytes, okay? And melanocytes are in 5 various places in the body, believe it or not, if you don't know. The skin, the eyes, the hair, the ears, believe it or not, and the fifth one escapes me. The fifth one escapes me. I'll get back to you on that. But essentially, your hair will then lack pigment, and if you look at albinos, they generally yellowy hair. The eyes, the iris of the eyes do not have pigment, and so when you look into the eye, you're actually looking straight through the eye onto the red ocular vessel at the back of the eye, and so the eyes actually look red. And of course, because the pigment, which is called melanin, is such an important sun protector, and we'll look at that when we look at tanning and ultraviolet radiation, because melanin acts as a sun absorber, as an absorber of UV radiation, it is, of course, very important for albinos to not only stay at the sun, but if they are going to go into the sun, to protect themselves from the sun, because they are, in theory, more susceptible to being damaged by the sun. Now, ridiculously, and this is where scientists often scratch their heads, albinos do not have a very high incidence of cancer, of skin cancer. And why that is we have no idea. We're looking very hard at why that is. The other thing that I just want to highlight here is that melanin comes in two forms. We get eumelanin, which is a black melanin, and I hope you can see this writing because it doesn't project very well in the red. Eumelanin, which is black, and pheomelanin, which is red-yellow, okay? And now, if you take the black and the red-yellow, and you were to put it on an artist's canvas, it is the combination of those that gives us every shade of skin that we've ever seen. The ratio of a red-yellow, if the ratio is higher, red-yellow, to black, we get Asian skin, right? We get yellowy Asian skin. If the ratio is high of eumelanin versus of pheomelanin versus eumelanin in the hair, we get reddish brown hair. We get reddish hair, red hair, like the Celtics. I'm looking around the place for Irish roots. Okay, we get red hair, and if we up the black ratio versus the red-brown ratio, we start to get shades of brown. We start to get shades, and eventually we get to pitch black hair. And so that is how the body has controlled not only the color of the hair, but the color of the skin. Okay? Of course, artificial ways of increasing the color of your skin, of increasing the amount of cement bags, the amount of pigment bags made are all possible today. Not always highly advisable, but possible. And we'll talk about one of my pet hates, which is a tanning bed and tanning salons. But we'll get to that a little bit later. And so when we define skin as dermatologists or as cell biologists, we define skin via 6 shades. Okay? 6 shades, which we call the Fitzpatrick scale of shades. And this was a long time in coming. Dr. Fitzpatrick from the US decided that the time has come to categorize, and I don't like to use the word categorize, but there's really no other way to describe it, categorize the shades of skin according to different features that the skin actually has. And I'll explain those features right now. So, and this I just found, it was a beautiful picture. I don't know half of these women, but they are quite well-known celebrities. Beyonce over here, and this is Lupita Nyong'o, who got the Oscar the year before last for 12 years as a slave. She's got I haven't met her, but she's got the most beautiful black skin, probably that I've ever seen. The Fitzpatrick scale goes along with how the skin reacts to UV, for example. And so skin type 1 is very fair, okay? Very fair, generally redhead, Celtic roots, and it always burns in the sun, and it does not tan, unfortunately, okay? As we go on, we go through levels of brown and sort of off brown and brown. The types of skin, Fitzpatrick 4 and 5, which tends to tan and hold its tan, actually get browner, okay? You will obviously lose the tan after a while when you get out the sun, and we'll talk a lot about tanning in a short while. And then, of course, you get the dark brown to black, which does not tan at all, is pretty much inherently protected from the sun. But when I say inherently, the sun these days is so intense that we're seeing more and more black skins getting cancer. And the levels of cancer is on the rise due to the increase in UV radiation, even though you have a black skin. And that's also one of the myths that we want to dispel, is that black skin does not get cancer is incorrect, okay? Black skin gets cancers if you do not protect it as well as you do other types of skin. And so that is how we've sort of leveled and categorized the different skin types. Now you can see, folks, if if you go into a salon or into a pharmacy and they tell you, this is your sunscreen that you need. This is a sunscreen, this is the best on the market, costs you 650 Rand, but it is the greatest sunscreen on earth, and you have to get it because of our sun, right? I love when people come to me like that in pharmacies and tell me, and I just say to them, you chose the wrong person today, okay? So I will say to them, so have you ever heard of Dr. Fitzpatrick? And they'll sort of look at me and say, are you Dr. Fitzpatrick? I'll say, no. But the first question you need to ask me before you sell me your sunscreen is what type of skin I am. Why? Because the type of skin I am is going to depend on how much SPF I need, on how much sun protection factor I need, and that sun protection factor is then related to your cream, okay? So you need to ask me, are you a Fitzpatrick type 1? Because no matter how much, even though you want protection, you are not necessarily going to tan, and you would need a higher SPF as a Fitzpatrick 1 versus a Fitzpatrick 5, okay? So I will need an SPF, I'm a Fitzpatrick 4 and 5. I will need a much lower SPF, and very often they don't even know what SPF means, okay? And so I'll be standing there for about 15 minutes with them when suddenly somebody has called them. Listen, I really have to go now. And off they go. Okay, so what I want to just finish with today, because I've almost kept you long enough, what I want to finish with today is looking at a couple of the myths. And this is one of the myths. My skin is darker because I have more melanocytes. Right? So the theory is that if the melanocyte is producing the pigment, that if you've got more melanocytes, that people with darker skins and thus more pigment must have more melanocytes. That was the theory. And so scientists had heard that for a long time. And so they decided, let's actually put this theory to the test and let's see what we can do. So what did they do? They took all the vast shades that they could. So white, light brown, or just off white, brown, and black, okay? And they took a biopsy out of each of these. And this was a huge study. They took a biopsy from each of these, and we have the ability in our labs these days to take a biopsy and to break it down into the individual cell types. We've been doing it for years. And so you take out the melanocytes, and you can actually count them, right? You can stain them in the skin that you've taken off, and you can section them, and you can actually get these beautiful spreads of very thin skin, and you can stain the melanocytes, and you actually stain the pigment or the enzyme, and you get these black melanocytes coming up on the surface that you're looking at. You magnify it, you can count them. And so they counted thousands and thousands of these sections. And what do you think they came up with? What do you think the answer was? You're too clever. Those are the melanocytes in the skin. That's how they look. And just to show you this remarkable picture, these are the individual melanocytes, and you can see, and this is a live skin, by the way. It's a real human skin sample. The melanocytes and the dendrites that stretch out from them to the surrounding keratinocytes in the white. And of course, they looked at it and they said that they all have the same number of melanocytes, all right? Roughly the same. And it was ridiculous how close the numbers actually were. They weren't even statistically different at all. So that's the truth. We have the same number of melanocytes. So why, then, is my friend who lives up the road from me much darker than I am if we have the same melanocytes, right? If we have the same number of melanocytes. Well, it then shows that it is just the production of the pigment that changes, right? So the level of production of the pigment, the level of the number of cement bags, as it were, right? So the gentleman in front is producing slightly less cement bags than I am. And that's the only difference. There are ways that we can increase the production of the cement bags. You shine UV on you, and you naturally increase the production of the UV bags, all right, of the cement bags. And so you can increase the levels of pigment production, but essentially we all have the same number of melanocytes. The other myth that was going around a while back is that a lighter or a darker skin is a beautiful skin, okay? And some people were saying, oh, you've got light skin, you must have lots of problems, you've got lots of spots that you can see, etc. And believe it or not, folks, these might seem superficial to us, but you put a grade 3 or a grade 4 learner who is lighter skinned next to a darker skinned kid, and you hear these terrible stories of the guy saying, no, my skin is better than yours. Of course my skin is better than yours. That's what my mother says. Okay? Which is just a myth. The truth is that a healthy skin is a beautiful skin. Okay? All skins are beautiful. A healthy skin is a beautiful skin, and there's no one skin better than the other. And so what I want to just end with this morning is this frequently asked question series that I have, and I'll just show you one today. But what I would encourage you all to do is to, if on your drive home, on your walk home, as you sit and reflect on the wonderful lecture this morning, on the lecture this morning, I'd like you to think up questions that you may have and just jot them down so that we can address them when we have the open session towards the end of the lecture. One of the frequently asked questions, and I often give these talks at high schools and at group meetings and things like that, and I've collected a number of them over the years. The one was that I thought I'd just share this morning was, what is a bruise? Okay, so people often say, I'm pink and blue, I've got these bruises, I don't know where they come from, but if they say, what is a bruise? Now a bruise, and this is once again a three-dimensional look at that skin that we looked at, epidermis in purple over there, the dermis and the hypodermis. If you were to knock yourself, okay, you would knock yourself hard enough to basically, if you were just to scrape yourself. So, for example, a carpet burn just takes off the epidermis. Generally, it just sort of scrapes off the top of your skin. It may not even bleed, all right? You just see this white. So that really does nothing and will heal quite quickly. Why? Because it is only the top surface of the skin. It is only the epidermis. If you were to bruise yourself in a decent way, you're generally knocking yourself much further than the epidermis. You're knocking the dermis, which contains the blood vessels. And as you knock the blood vessels, they burst, right? And so as the skin heals, the first thing that is happening is that the blood is actually bleeding into this area, all right? And so together with the inflammatory response and with the healing response, we get the blood bleeding into the area, and that blood is the blue that you see, okay? Of course, it goes red first because that's the fresh blood, and then as the blood pools in this area, it tends to get blue, and so your bruise will get blue. But over time, the blood vessels heal, the blood is removed by the immune system, and of course your bruise heals, right? And so for a lot of the teenagers, I throw the next bit in. So if this is a bruise, so what happens if you add lips to the top of the skin and you give it a good suck, right? What you're actually doing is you're creating so much suction on the top that you're also breaking blood vessels. And so then it becomes a love bite, okay? And so what we should theoretically or biologically call a love bite should actually be a love bruise, all right? So folks, with that being said, just in summary, this morning, the skin is the largest living organ of the body. it is temperature sensitive, water sensitive, and sensory. It's a sensory organ. It gives us our color and makes that lasting impression that we spoke about. It is only 1 to 2 millimeters thick, and as we know, it is often caught in the midst of controversy, and lots of wars have been fought over it. I don't need to remind you. However, it is the one that we are born with. It needs care, and it is the only one we've got. So thank you very much for listening, and we look forward to the rest of this week. I think we have probably 2 minutes for questions. If anyone has a burning question, I see a hand at the back and a hand on the side. Yes. Sorry? Yes, thank you very much. So the question is, how do you get rid of a bruise? Well, it depends on the severity of the bruise, really. But creams, generally, it will resolve over time itself. So just rest. And you can enhance it slightly by adding some antioxidant creams or creams that have very little amount of retinoids in it, like vitamin A, vitamin C. That works. That activates the healing mechanism in the skin. Yeah, there's one there, and then.
Can you increase or augment that enzyme? If so, how?
Yeah, thank you very much. So the question is, can you increase the tyrosinase, the enzyme? And so we can accelerate it. But what we're now finding is that as people go more towards the natural process and try to get natural remedies, we found that there are certain plants that have compounds resembling tyrosinase. And so yes, the big multinational companies have jumped on it very quickly because they can activate the tyrosinase, or it can act as tyrosinase, so you can augment the tyrosinase production, and they put that in tanning creams, for example. And then obviously the opposite to that, if you have a tyrosinase inhibitor that you also find naturally, you can add that into creams and slow down the production of pigment, or even completely lighten your skin chemically. You can do that. Can you ingest tyrosinase? You can, but it wouldn't work that well because it has to get into the cell first, and the cell makes it. So your immune system will probably catch it long before it gets into the cell. The ingestion, so what I didn't say was tyrosinase stems from tyrosine, the amino acid tyrosine. And tyrosine you can ingest. You can ingest amino acids all the time. We do it all the time in vitamins and pills and things like that. So if you give enough tyrosine, you probably can increase slightly your tyrosinase because that gets into the cell. Yes, you had a question. So thank you for the question. The question again is what makes your skin get all hard and tough over time? Well, it's simply that as you're walking on it, you're actually activating the levels of cells that actually are dividing. So you're increasing your division of cells as you give it the mechanical force, and you also know that with people who work with their hands. Their hands are particularly hard and even scaly. Because of the mechanical force, they're increasing the production of the cells, and so many more cells are being shoved up towards the surface, and as they get to the surface, what happens is they actually fill with keratin, which is a very hard substance because it actually oxidizes. Gets very hard, and in fact, a rhino horn, for example, is made entirely of keratin. And keratin is the basis of our hair. So it is the outer sheath of your hair. So when they say that rhino horn is actually compressed hair, it is exactly that. But it's keratinized, extremely hard substance, and that's what gives you your hardness of your feet. In fact, you know, the guys who run over coals and questions how far we still need to take this research. All right, so let me start by giving you a week overview. And this adventure is going to start today, where we talk about what is skin, what makes it important, how do we get our skin, how do we get color in our skin, what generates the color, how we can alter that color, for example, and then a few myths. I will end with a few myths that need to be dispelled almost immediately. I will also have a session right at the end of virtually every lecture where I have a frequently asked question session or a Q&A, a question and answer session, which is just an open forum, all right? We've sealed the doors, so if you want to ask any personal questions, please go ahead. Nothing leaves this room between you and I. So we then, tomorrow, we'll look at, and I really want to, let me just go back. The title of this week's lectures was The Skin, the Good, the Bad, and the Ugly. But we don't like to call things ugly. So I've changed it. The good, the different, and the not so good. All right? And so we'll use that thematic approach as we go through the week. Tomorrow, we'll look at skin physiology. What is UV or ultraviolet radiation? How does that affect us? What is SPF, sun protection factor? We see SPF 10 and SPF 20 and SPF 50 and add this and add that and take of this and take of that all over our television. Skin from a biological point of view, but also the skin from a psychosocial point of view. And that culminated last year in a very nice interdisciplinary collaboration with the social sciences, where we could look a little bit deeper at what make people try to change their skin color, and what is their thinking behind it, and what is the sort of mindset of people wanting to change their skin color, whether it be darker or lighter. And so this week, we're going to progress down this adventure where we're going to look at lots of things. And I urge you to be very interactive with me. I promise I don't shout at people. I do enjoy the interaction, and there are so many topics, there are so many nuances around the subject that I would like you to raise some of them. If I am going to cover them in the lecture series, I'll let you know. If not, I may flag it, and we'll come back to it, I promise. And so let's be interactive. So just, you know, breathe in, breathe out, relax. This is not a note-taking lecture. It is hopefully very visual, and I'm hoping that we learn quite a bit as we go through this week. And I'm also hoping that you can teach me through your...
I'll put it onto the website when I have a spare moment at the weekend, if you'll just forgive me for running until then. Okay, thank you. Thanks, Lester.
Thank you very much. Daniela. And good morning, folks, and welcome to the summer school. I'm hoping that my mic is sufficiently loud enough, so if you cannot hear me at the back, I'm good. Okay. My testers at the back have arrived, and they've told me that my volume is good. So thank you very much for attending this week. We're going to have a bit of an adventure this week, an adventure that will start today and that will end hopefully with you learning a little bit more about yourself, more than about me, and almost more than about the subject. For those of you, so let me start by saying what I'm not, okay? I'm not female, obviously. I am not a medical doctor. I'm a PhD. And I'm not a dermatologist, even though I work extensively with the dermatologists. I wish I was a surgeon, but I'm not. So what I am is a molecular and cell biologist, and that's what I've trained in, with a specialty really in skin research. And so I've spent the last 10 to 12 years really trying to understand not only the subject, which is burn research, and the terror of being burnt and what actually happens and how the skin heals after that and what we're currently doing relating to burns research. And then cancers, skin cancers, non-melanoma and melanoma skin cancers. We'll delve into what it is and see what the current treatments and the theories around healing people with skin cancers are. Lecture 5, I finished the week with a lecture called Hope. And this is skin research and the incredible commitment of researchers worldwide to try to find answers relating to not only cancers, but the biological mechanisms that relate to cancers. And so we'll look at the current skin research, we'll look at current treatments, I'll also throw in there what my lab has been doing. I left UCT last year, at the end of last year, to start my own lab, and so I'll chat a little bit to you about what we're planning to do going into the future relating to skin research. All right? Sound good?
Yeah.
All right, so let me start and say that if you were to describe skin, it is 6 million years old. We expose it to the elements in all sorts of ways. We cover it, we paint it, we tattoo it, we scar it, and we pierce it. We do a whole lot of other vision sets and all over the media. We'll explore a little bit what it is. And then, of course, the aspect of can we go into the sun? And if we do go into the sun, how long do we go into the sun? Or should we just avoid sun altogether? And that relates to vitamin D. We'll talk a little bit about folic acid and folate. In lecture 3, we'll talk about the skin as the different. The different, where we talk about tattoos. What are tattoos? How do we get tattoos? Are they permanent? Are they not so permanent? Are they terrible? Are they nice? We'll talk about tanning. If you want the perfect tan, that's your lecture to be in. And then we also talk about my other pet subject, which is skin lightening. Skin lightening and why people lighten their skins. And it's a very hot topic at the moment because the cosmetics are just filled, the cosmetic shelves. And this is where I go into a pharmacy and my wife has to come call me out after an hour and a half because I'm standing in front of the cosmetic shelf for the last hour just looking at the whole range of products and reading every bottle as we go along. So skin lightening and what it is it a farce? Is it just a means of a sale or not? Lecture 4 is what I call the bad and what happens when things go wrong. We'll look at a few skin pigmentary disorders. We'll look at what happens when skin actually burns. And that's my other pet subject.